Oh, hi. Good morning, good afternoon, good evening, and good night. My name is Yap Chong Lee. Matrix number AA241525. I'm a diploma in mechanical engineering student in University Tun Hussein on Malaysia, UTHM, in the Pago branch. And today, me and my team are going to present about the bending moment and the shear force that is contained in a garden tool, specifically a garden spade. Now, when we think of the shear force and bending moment in a beam, the first thing that we will think of out of every tool in the world is a garden spade. And since we do not have a garden spade right now, let me use a badminton racket to demonstrate how to use a garden spade. Of course, we need to push, we need to step to apply the extra force to dig the garden spade into the ground, and we pry it up. Before we start any presentation, let me tell you a bit about the problem statement. Again, I shall use the badminton racket as a demonstration, which is normal garden spades is too long and there is no handle. So the exertion of force, the force efficiency is not as good. Next, since I already said that we need to step, there is no folded edge at the spade itself. And let me pass the mic to my friend.
Hi, my name is Lashiong and my metrical number is AA240200. Now, we're going to continue with what has been stated by my fellow classmate Yap Chong Lee. The main problem that we have here is that the T-section of the current product of spade has an unfolded T-section. Another problem is that when it comes to cheap spade, they don't include a D-grip. Now, with the absence of D-grip handle, it increases the risk of the user developing blisters. Because without the handle, the user is exposed to wooden shaft, and when it comes to wood, you can get blisters from it. Another thing is that it may cause wrist strain under torsional loading. Next, heavy material. Why? The blade of the spade itself are often made of heavy material such as carbon steel, which is why we're proposing a new material later on in the next chapter. Now, moving on to the last one, which is the loose fit of the socket end. Now, as you can see here, when the socket is loose, it causes uneven mass distribution, causing point loads at the end of the socket and at the front of the socket itself to the shaft. When we have a tighter fit, it causes an even distributed load, which lowers the chance of the shaft breaking. Now, moving on. Now, as I've stated in the problem statement, with the problem with shaft and the socket itself, we are going to calculate and compare the mechanical impact of point loading versus distributed loading to the shaft itself. Moving on to the second one, we are going to determine the shear force and bending moment diagram to identify the critical failure location at the shaft. For the third one, we are going to study how the absence of a D-grip affects user control and risk torque, along with the risk behind the ergonomics and safety. And lastly, we're going to propose a precision fit tapered socket design that utilizes high-strength 7075 T6 aluminum alloy, which its reason will be discussed later in the next chapter, and a folded foot thread to maximize load distribution, reduce tool weight, and improve the overall factor of safety.
Let's talk about the scope of study. Now, this analysis will be conducted using the material properties of ash wood for the handle and high-strength 7075 T6 aluminum alloy for the proposed socket and blade assembly. The study will focus on the stress distribution at the socket handle interface and the effect of adding a folded thread, flange, to the top of the blade. The study will also analyze a horizontal prying force of 350 newtons applied to the socket, which holds the blade and shaft together. Lastly, this analysis will consider static forces only and will not account for environmental degradation such as rust or long-term UV damage to synthetic components. As for the literature review, first, we will talk about the human prying force and ergonomics. Now, as you can see, as the picture shown, this is the physics of what is going on when a human is using a shovel or a garden spade. Now the next picture shows the grip strength norms in kilograms for male and female. The determination of loading conditions for hand tools must reflect realistic human force capabilities. During spade operation, a dominant load is the horizontal prying force applied by the user when levering material. Ergonomic studies indicate that the typical pulling force of an average adult male ranges from 300 to 400 newtons. Thus, a prying force of 350 newtons is considered a reasonable and representative value for the analysis of spade performance. As for the selection, why we choose the 7075 T6 aluminum alloy for socket and blade assembly? This is because the 7075 T6 aluminum alloy has high strength to weight ratio, which improves both structural performance and usability. With a yield strength about 500 megapascal, it can better resist plastic deformation under high digging and prying loads compared to conventional mild steel. Its low density of approximately 2.81 grams per centimeter cubic also makes the spade lighter, reducing user fatigue and improving ergonomics.
Okay, my name is Tarwi Mulitaran and my metric number is AA240145. So now I'm going to explain about the stress concentration at the holes and bearing, behavior and American black ash wood handler. So these are the image of stress distribution around the circular hole in the blade, showing localized stress concentration near the hole due to the geometric discontinuity. And then the next image is about the schematic of a typical 3-point bending test where when a beam is supported at the two end point and load is applied at the midpoint. So the presence of a mountain hole in a spade handle creates the stress concentration by the distributing the uniform stress distribution in the material. Classical solid mechanics theory shows that a circular hole in a beam under the tension of bending can increase the local stress by the approximately 3 times the nominal stress, which means Kt equals to 3.0. In addition, the fastener apply bearing pressure on the inner surface of the wooden handle, increasing the risk of localized crushing. Although American black ash has a flexural yield strength of about 100 to 120 megapascal and good stiffness for the resisting bending load, the mounting hole remains a structural weakness that must be carefully considering in the design. Next, I'm going to explain the safety consideration. First is the safety importance. Safety is critically in digging spade designed due to the high digging, praying and foot load during the use. Second is the issue of conventional open pocket spade. First, loose fit between the handle and socket cause the high stress concentration at the handle mounting hole. Second, localized stress can lead to sudden handle failure during the heavy praying. And lastly, sudden failure may cause loss of control and potential user injuries. So, advantage of the proposed taped socket design is to distribute the applied load more evenly along the handle and reduce the stress concentration at the mounting hole, and lastly lower the risk of the sudden handle breakage. To improve the foot tread design, first we have to fold foot tread, increase the blade stiffness, and lastly reduce the likelihood of the blade bulking under an under 80 Newton foot load.
Now, we're going to move on to our project implementation, which first we're going to discuss on the flowchart that we made for this project. We first start with our product selection, which is garden spade, and the case study identification. Now, for problem identification, we've already stated it in the 4 problem statement that we made. We then move on to literature review and material sourcing, which then goes to existing design analysis and development for proposing new design. Now, after that, going to decide, does the new design reduce maximum bending stress and satisfy the safety factor? If not, we're going to redevelop and repropose new design. We then move on to CAD modeling, which we've shown previously, and the safety, health, and environmental assessment. Now, let us see our final proposed design. Here, we have added the D-grip, and our socket is perfectly fitted onto the shaft with the blade having a flange. Material selection. For the blade, we use aluminium 7075 T6 as stated, and for the shaft, we use ashwood, handle also ashwood, and for the grip for the handle, we use plastisol, a soft plastic. Safety consideration. Tapered socket design. This allows for the distribution of applied load more evenly and to reduce strength and to reduce the stress concentration at the mounting hole. Next, the folded foot tread, which is to increase the blade stiffness and minimize likelihood of buckling, and the material we use is 7075 T6 aluminum alloy to improve safety by improving high strength while reducing tool weight. Health and ergonomic consideration. Ergonomic D-grip handle is added to improve the torque transmission. Ergonomic D-grip handle is added into the shaft to improve the torque transmission, and lighter spade weight through the use of 7075 aluminum to improve handling and minimize repetitive strain. For the foot tread, as we've stated, it enhances the folded foot tread, as we've stated, which also enhances the comfort by distributing foot pressure more evenly. Environmental and consideration. The material usage of 7075 aluminum reduces material waste and resource use. The tool lifespan is longer due to better load distribution. Recyclability. Since material used are wood and aluminum, they are easily recyclable. And manufacturing efficiency, since both of the material are highly used in the industry today. Not much of the disposal impact since the tool is long in its lifespan. Now, moving on to the project design stages. Stage 1, conceptualization and ideation. In this stage, we research on conventional garden spade and we decide on what to add or what to fix, such as adding D-grip to the end of the tool to make sure the force is efficiently distributed and won't cause harm to the user. Stage 2, material selection. Just as we've stated that we chose the aluminium 7075 T6, and stage 3, which is structural refinement or the preliminary analysis. Since the project is imaginary, many values must be assumed. The free body diagram, shear force diagram, and the moment diagram is included in the calculation. Stage 4, which is CAD modeling and drafting, which we use SolidWorks. And lastly, stage 5, final review and safety audit. Final checking were made and elements like the drawing or calculation are rechecked and added into the report.
As a conclusion, the garden spade is a helpful gardening tool for moving or removing dirt or any type of sand. This shows the importance of it being a useful and handy everyday tool as a gardening tool. As for this project, the garden spade makes a splendid example of demonstrating the solid mechanics theory of shear force and bending moment owned by Irvin. The calculations and graph sketches are made to assist students to understand the complex theory better. Thank you very much, and I will see you guys soon.